Hello again. Today we're going to be talking about related rates, what they are, and how they're different from derivatives that we've been calculating so far. So let's get started. Up until now, every function has had two variables. There's been an independent variable and a dependent variable. So for example, area was pi r squared. So if I needed the derivative of area with respect to radius, that would be 2 pi r. Similarly, if I had a cube and I was looking at the volume, we know that volume is equal to the side length cubed. So the derivative of volume with respect to side length is going to be 3s squared. But what if either of those changes or both of them change over time? So for example, if the radius of a circle changes over time, then the area of that circle is also going to change over time. And there's a relationship between those. But radius is no longer the independent variable and area isn't either. It never was. Now time is the independent variable and both radius and area depend on that. So if I use chain rule, I can differentiate area equals pi r squared in a different way. If I differentiate the left-hand side, that's going to be the derivative of area with respect to time. But knowing how chain rule works, that's going to be the derivative of area with respect to radius times the derivative of radius with respect to time. And I already know that the derivative of area with respect to radius is 2 pi r, so I'm just going to plug that in. And then the question that I'm given will likely have some information about either the derivative of area with respect to t or the derivative of r with respect to t. And then I can plug that in and figure out the unknown value based on everything that I've plugged in. All right, some more examples. We already talked about the volume of a cube being side cubed. So if those are changing with respect to time, then I can say the derivative of volume with respect to time is the derivative of volume with respect to side length times the derivative of side length with respect to time. I already know that the derivative of volume with respect to side length is 3s squared, so I can plug that in. And I should get some information about one of those other two quantities that are in that equation. Another formula is that the volume of a regular octahedron is given right there. So if those things were changing with respect to time, then I could write that formula right there. I do know that if I'm given the volume formula that has s in it, then the derivative of that is going to be root 3 times s squared. And then again, the question will likely give me some information about how volume is changing with respect to time or how the side length is changing with respect to time. Now, sometimes area equations, volume equations, those things that we've done before, they have multiple variables in them, and they are all changing with respect to time. So I might have to use a product rule to do that. So in this case, on the left-hand side, I've got the derivative of area with respect to time, but then I need to use product rule on the right-hand side to say that 1/2 times the base times the derivative of h with respect to time plus height times the derivative of base with respect to time is going to be on the right-hand side. And then I'd have to have some more things to plug in. Volume of a cylinder, same thing. I've got more than two variables in there. So when I take the derivative, I've got dv dt equals pi r squared times dh dt plus 2 pi r times the height times dr dt. Again, product rule. And just as likely, I might have to do quotient rule. So I know that the tangent of an angle uses theta. It uses y as one of the side lengths of the right triangle. It uses x as another side length of the right triangle. So there's my relationship right there. But then when I take the derivative of both sides, I've got secant squared theta d theta dt equals x times dy dt minus y times dx dt all over x squared. So hopefully I'm given some more information about how those things are changing. But that's just a quick little introduction to related rates and what it's going to look like. You're going to take formulas that you already know, but now time becomes a factor and you have to change everything accordingly. If you have any questions, please let me know and I will see you tomorrow.